I actually move around a little bit when I'm talking. So if I lose the mic, put your hand up and I will remember to speak a little bit louder. Thank you very much for coming to my talk. The talk is slightly named differently on the bill. I don't know how that happened, but the talk is actually called The Sane Way to Build Cloud Infrastructure. Okay. Please, please, please forgive the word sane. I was told off this morning because apparently that's a bad word that I should use in a slide. If it means offense to anyone, I'm sorry. I'm sorry. My name is Paul Stack. I'm on the internet at Stack72 in most places. I tweet a lot, so if you don't like crap in your Twitter stream, don't follow me. It's probably the best thing to do. I do occasionally tweet some things that are interesting. I work at a company called HashiCorp. Anyone know HashiCorp? A couple of people. So HashiCorp create tools along the lines of Vault, Terraform, Packer, Vagrant, and a few others. Okay, so it's starting to become much more well known, and the correlation between coming to events this year, now that I work at the company, and last year when I didn't, the amount of people that know the tools is becoming a lot more. I love infrastructure. Any infrastructure people in the room? Excellent, excellent. These are all my favorites so far. Okay. So the way to think about infrastructure for me is you can create the best applications and the best code that you want, but without the infrastructure under the hood that works, you can't deploy it. It doesn't happen. Okay? And I'm sure we've all worked in a company where our infrastructure team or our operations team can't move fast enough. This talk hopefully will give you ideas in order to take back to your company in order to help solve those problems. This talk is not about containers. It's not about containers, okay? I will probably have some beers later, and I will probably rant about containers. So apologies in advance. It is definitely nothing to do with serverless, okay? Another buzzword. And it's 100% nothing to do with nano pico or microservices or whatever you want to put in there, okay? Hype happens everywhere. This is bog standard building systems in the cloud and thinking about building systems in the cloud in a more scalable format. So we have a very brief history of infrastructure management. I have a few slides, and then I'm going to go pure demos, okay, because it's much better. I like actually showing code much better. Firstly, we had what was called Snowflake servers, okay? Now, Snowflake servers is something that's been around for a long, long, long time, but it was just coined in 2012 by Martin Fowler, okay? Now, a Snowflake server is the idea in most organizations that it's a physical piece of infrastructure, usually, that has been manually maintained by a lot of people, okay? Usually the SSH in or the RDP in, and they like install stuff on the fly. And then they would move to the next machine, and RDP in, and SSH in, and install something else on the fly. Okay. Now, fair enough, they follow a specific pattern, they know what they're installing, but because it's done in two separate transactions, you cannot guarantee that the machine is exactly the same. There are very unique differences, thus it was coined as Snowflake. Snowflakes are all generally, they look the same, but when you examine them closely, they're very slightly differently. Unfortunately, Snowflake servers are usually managed by a runbook. Is anyone still working in an organization where runbooks are still apparent? I used to work in an organization up until last year that had a 56-page Word document as the first part of the runbook. It was for a Windows 2003 server. Not even joking, okay? In 2015, 2014, we were still actually installing Windows 2003. Not a problem in itself, don't get me wrong. But after you follow the first 56 pages, which still had some screenshots of Windows 2000, because nobody thinks to update runbooks, right? Because it's that Word document that's written once and is just forgotten about, or it's written on a wiki and you can't remember what the link is, so you then create your own version. But then more importantly, we had a 28-page security document that followed up with it. And I pointed out at the time, I was like, hey, runbook, security document? Isn't it technically the same thing? Shouldn't it be part of the same thing? Oh, they were created by two different teams. Yeah. What it leads to is thinking of your servers as pets. Okay. We have a pretty cat and we have a pretty puppy. And if anything happened to these pets, we would be distraught. We would be upset. We would want to do everything that we can. We take them to a vet. We nurse them back to health. We spend crazy amounts of money in order to get pets medication. Okay? It also usually has a name. Servers have names. Why do servers have names? It's crazy. Then we realized that that was possibly not the best way that we could manage our infrastructure. And then configuration management tools were made apparent in maybe 10 years ago. So you have Chef, you have CF Engine, you have SaltStack, you have Ansible, you have Puppet. Anyone use any of these tools? They're starting to become much more fashionable, right? There's been people using these tools for maybe 10 years now. Okay? And 10 years ago, people actually declaring their infrastructure using Chef or CF Engine. That's incredible. It really is. What this tool does, if you don't know what a configuration management tool is, it allows you to declare the state of what your system should look like. What I mean by that is when a server comes up, it should have Nginx installed. It should have user X installed. It should have the folder will have permissions for the correct user to read. It will have specific packages installed on it. It will have services in a specific state. It's a very declarative way of specifying your infrastructure. And what it created was this idea of a Phoenix server. Okay? Phoenix server is a wonderful idea because it means that as soon as it's destroyed, it will rise from the ashes and be exactly the same. Okay? And this was another term coined in 2012. This is nothing new. This is just terminology that has been added throughout the past few years. Okay? This one also came out of ThoughtWorks by a lady called Cornelia Siestma. And basically, when I used to give this talk before I moved into the immutable side of it, I used to actually go at this point and destroy production servers and be happy destroying production servers. I can go and do, actually, you know what, let's go and do that. Why not? Just to show people that I'm more than happy to do it. Da, da, da. Let's go and destroy my production integration server. Da, da. This is like not supposed to happen, so you'll have to give me a second. I didn't plan on this part. Da, da. If I can spell my own name right, that would be really good fun. And let's go and copy that, paste it there. Let's hope MFA is not on. Good, it's not. And let's just go and destroy something. Running instances. Let's just take down my TeamCity server. Boom. Gone. Don't really care. It's fine. We'll come back to that one later. That'll be an interesting demo to see if that worked. Let's sign out. Let's hope nobody gets paged. And let's continue. So the idea here is that I'm in a state right now with my infrastructure because I follow good patterns that I don't care if anything dies. Okay? It's not a pet to me. It can be destroyed and it can be brought up in exactly the same format. Now, unfortunately, when you use specific tools like this, with great power comes great responsibility. And this was a message posted on Stack Exchange maybe 6 months ago. And the TLDR of the screenshot is somebody actually ran the command rm-rf across their root volumes using Ansible. Okay? Now, I don't know why you would have not got fail-safes in place in order to stop that, but it shows the fact that when you have tools like this, they can be abused and they can cause real problems because there's a greater level of risk in your system. Okay. Usually in the old world, you would have ACLs that would stop people running commands in there, or you would just completely stop people from SSHing into machines or RDPing into machines. Now, when you've got a tool that can do that for you, that's kind of scary. It actually so happened that this was a complete troll, and I don't understand why somebody had enough time in order to go and craft a question on Stack Exchange about this. The guy obviously needs a better job. But it just so happened that it got a lot of feedback from the community, and like the responses range from "you're stupid" to "why are you even managing infrastructure?" The idea is that long-running servers suck. Okay, they suck. They really are very bad because Your development machine is going to be very different to your production machines. Hands up who develops on a Mac. Hands up who actually runs their software on a Mac in production. Yeah. See, we always introduce changes into our environment and our infrastructure that it makes it very difficult. Then we had the advent of the cloud. Okay. Does anyone want to take a guess when the first cloud service came online? I'll buy you a coffee if you get it right. Excuse me? 80s. 80s? Not quite that. That would have been before me, but anything else? Anything later? 90s. the 90s. Good shout. Yeah. So it was actually Salesforce.com in 1999. Okay. So 17 years ago was the first idea of software as a service. Okay. 17 years ago, I wasn't even in IT. No, I wasn't. I was at university. Okay. And I can't think of, I don't even remember using the internet a lot back then. I used to use it for uni and like surfing all sorts of crap on the internet, but I never used it in order to use software because we always installed software on our computers, right? It was never available on the cloud for us. Amazon actually launched their first service in the cloud, AWS, in 2002. 3 years later. 3 years. Okay. Anyone want to take a guess on when Azure finally decided that the cloud might be a thing? 2010. 8 years after. So Microsoft have been in the cloud now for 6 years. And they're really like accelerating the catch-up game. They really are. The cloud was the new way of delivering systems. It was the new way that we could get our systems into production faster and get our customers using them faster. But we needed a completely different mindset when we manage our systems in the cloud. When you launch an instance on Amazon or Azure, if you launch it today, you have zero guarantees that that actual instance will be there tomorrow. Because they have their own infrastructure under the hood. Okay? They may have a failure. They may have to introduce a new security patch. They may have to rotate your servers in order to actually get some systems more secure or upgraded hardware or something like that. So you have to think very differently on how it goes. And this is where the idea of immutable infrastructure came into place. Okay. So immutable infrastructure was termed in 2013 by Chad Fowler. Okay. And he wrote a blog post back then, and he said, trash your servers and burn your code, immutable infrastructure and disposable components. It's a great post. Any functional programmers? Functional programmers decided, actually, it's not really immutable, is it? Because things happen, people log into web servers, logs happen, the state of the server changes. And last year, 2015, there was a conversation on Twitter by a few people, and they were like, maybe immutable is not the right word for it. Maybe we should come up with something better. And a guy called Mark Burgess, he wrote CF Engine, actually decided that maybe disposable infrastructure is a better word for it because it's been brought up and it has a lifespan and it can be disposed of and you're happy to do that. Okay. When you think of it as disposable infrastructure, we think of it much more as cattle. Okay. And I promise you this is like almost where my slides end. All right. Cattle are something that are bred for a purpose. Farmers don't give each of their cattle names. They usually have something like a number. Okay? And unfortunately, if something happens to cattle, they just get a new one. They don't like nurse it back to health. It has a specific purpose for being there. The same way as we should think of our infrastructure, in my opinion. Okay? I said I work for a company called HashiCorp. It's funny, one of my colleagues has just walked in, so I have to be very super careful now. The website is terraform.io. I'm going to give a brief introduction to what Terraform is, and then I'm going to go straight into code. Okay. So Terraform is a provisioning tool that will allow you to interact with many providers. Okay. And a provider in the Terraform land is something like AWS, Azure, Google, VMware, etc. So it can be many cloud providers. It can also be many software as a service providers, something like DN Simple, DNS Made Easy, etc., etc. There are a lot of things. So Terraform has a number of providers. As of this morning, there are 46 providers. Okay. Lots. Terraform is also very easy to extend. Okay? There is a provider model that you can go and you can build your own. There are many open source providers out there. I gave a talk at HashiConf EU earlier in the year about how to create your own provider. You can go and find it on YouTube. It's on there. But every provider has a number of resources. Okay. Now, resources inside a provider are the tangible pieces of infrastructure that we build. So, for example, a load balancer, an instance, a subnet, a VPC, a database instance. Those are resources. Terraform is built on graph theory. Okay. So, I'm not going to describe graph theory because it's much more complex than I can understand. The way to think of it is, it has nodes. Think of your resources as nodes, okay? And it has edges. Edges are relationships between the nodes, okay? So you know that a security group relates to an instance. An instance relates to a VPC. A VPC relates to an Amazon account, etc. That's a very basic graph, okay? But in Terraform, we make it a directed graph. So we understand the relationships between your systems, and we know the way in order to build them. Okay? This is not a sales talk. This is open source. This is actually all open source. What I'm going to show you, everything here is all freely available to go and download and play with. Okay? But right now, because we actually build a graph and it's directed, we can walk the graph back and forward, and we can always check for any changes of our infrastructure that is required. I'm going to use two tools, both by HashiCorp. Terraform, okay, which is the tool I actually work on a day-to-day basis, and another tool called Packer. Okay? Packer allows you to create machine images, which are pre-created, pre-baked with everything that you require on them in order to actually spin them up. Okay? Packer can also create Docker images if that's what you would like to do. So the same thing. Let's go and look at some code. Everyone see my screen? Cool. So right now, I'm just going to prove to you that there is nothing in my CI account. I'm going to swap accounts and just show you that there's absolutely nothing in here. So we have one VPC, which is the default VPC that comes with Amazon. Okay, just if you launch a machine and you don't create something, it has to go somewhere in Amazon, and that's Amazon's cloud, Amazon's public cloud. Okay, I have no key pairs, hopefully, and we're going to start creating up some infrastructure as we go. Okay, this code is all available on my GitHub, and you can go and have a look. Please don't use it in production. This is demo purpose code only. Please don't use this in production. Please. This is not official HashiCorp code in any way, shape, or form. Okay, so what we do is we declare a provider. Terraform will always have a provider block declared. Okay, this doesn't have to be one provider per file. It can be as many as you want. I could technically say provider Azure RM, and I could say region equals West EU. And that would declare two cloud pieces of infrastructure being spoken to from this one single Terraform configuration file. Okay? Give me as many as you want. It doesn't matter. Let's remove that, because any Azure fans in here? I have to be really careful because I'm on camera. So, okay, I work predominantly in AWS, so I'm a fan of AWS. And then next, we're going to create a key pair. Okay, just a very bog standard key pair that gets attached to machines that we can SSH in and out of machines with. Okay, so I am going to switch to my terminal, and I am going to run the command terraform plan. Notice right now that the public key right here is pointing to a file on disk that's in the SSH folder called devternity.pub. Okay. Terraform is clever enough in order to say, when I run the command terraform plan, which we'll talk about in a second, it will try and validate what's going on. And it will say, oh, there's no such file or directory. So before it does anything, it already plans and tries to work out what is actually going on in your system. So we'll make SSH key. I'll skip that. And now if I run the terraform plan, it's actually going to create my graph, okay? And what it's gone and done is it will take the state of what's locally on my machine, and it will compare it against the provider that I am talking to, and it will work out any differences that it requires. So I'm declaring the state of what my cloud provider, my cloud infrastructure should look like. And it will come back and it will tell you, I have got one thing to change. Okay, so in this case, there's no SSH key. We're going to go and create an SSH key. And of course, we just Terraform apply, and it's going to go off and talk to the cloud infrastructure in a second, hopefully, if the Wi-Fi doesn't fail me. And as you can see, it gives you an output at the end. It says apply complete, resources 1 added, 0 changed, 0 destroyed. And if I go to Amazon and I refresh the page, I should see, if I actually click refresh, hopefully, we have a new SSH key. Okay. Really simple. Now, people are the worst, okay? Because people will go on to the cloud consoles and they'll tinker with things. All right? So let's see what happens when Terraform, well, so let's just go and somebody's deleted the SSH key. What's Terraform going to do now? Okay? So what Terraform should do is Terraform should detect that the SSH key is missing, and it should say, I need to add that key again. Terraform plan, and it will, hopefully. It will. It should. Otherwise, it's a bug. There we go. So it's going to say it's going to add it back. Okay? So Terraform, every time I run a plan, it is always telling me the differences in the state that I expect. This is extremely useful, as you can imagine, because being able to declare how your infrastructure works, things like security group rules, tags on machines, all of that is all very useful information. You don't want somebody going to your infrastructure and changing a security group on an instance. That could open you up to a vulnerability. You definitely don't want people going and changing tags on instances if you use that for cost purposes, billing purposes. So you want it to be declared, and you always want to do it. So let's apply that. If I could spell. And let's layer in another piece of infrastructure. So Terraform right now is currently in 0.8 RC1. I cannot confirm or deny that RC2 will be out very shortly. It will, like today. It's not public. It is completely public information, by the way, so it's all on GitHub. But what we decided in 0.7 is that when we decided to share Terraform configurations, it was very difficult to do because everybody who has an account on Amazon sees different things. Okay? So my Amazon account in EU West 1 can see availability zones A, B, and C. Okay? If I went to US East 1, I could see maybe B, D, and F. You could see maybe A, B, and D. So we thought, rather than getting people to hard code things like availability zones, we introduced the idea of what's called data sources. Okay? So I've introduced a data source right now, and that data source is going to go off to my Amazon account, and it's going to get all the availability zones that I can use inside my account. Okay, so that's going to do a query on the fly to Amazon and say, hey, give me the list of availability zones this person can use. And then we can use those availability zones. I'm going to introduce something called modules. As you can see, I have tested all this code this morning. So I just commented it all out. It's much easier. We're now introducing another concept within Terraform called modules. Okay? Modules, everyone developers in here? Mostly developers? Think of modules as a third-party API that you code against. Okay? It's a packaged piece of Terraform configuration that has an interface that you pass variables in and out of. Okay? Sometimes you don't care about what the internals are. In something like a VPC, developers generally don't care about the networking side of what happens in the cloud. Okay? If you have a very lovely ops team who will package up everything that happens in the cloud for you, enjoy it. Just bask in the glory of that. And they'll take care of your route tables and the associations and the subnets and all that rubbish. Okay? You just have to provide a couple of values. The values in this case is I want the name of the VPC, which is DevTernity. I want to declare a CIDR block. I'm definitely not going to talk about CIDR blocks because you will all be sleeping. In this case, the CIDR block is 10.0.0.0/16, which gives me 65,536 available IP addresses within my private cloud. Okay. If you exhaust that level, I want to come and work for you because that means that you're working at serious scale. And then lastly, we just declare some private and public subnets. Just ignore that interpolation syntax. We'll talk about that in a little bit, okay? And then look, I am now telling the VPC to be created in the availability zones that I have looked up from Amazon. Okay? So you can start to see the relationship now of what's going on. What's happening, in fact, we can graph it. Terraform has a graph function. Terraform graph. If I actually go and download the source code for the module. We just have a list of output. Not useful as a graph whatsoever. But we can pipe that through OmniGraph. So the keynote this morning talked about like creating documentation for your systems. That's not really documentation right there. So we can actually say Terraform graph and pipe it through dot, which is a package for OmniGraph, and save it as a PDF. Okay? And you can version it, you can do whatever you want, right? This is just useful because you can envisage the relationship between what's going on in your infrastructure. So let's save it as a graph, and let's open the graph.png. Yeah. Yeah. Right? That, to some people that actually makes sense, right? Because the way to think of it, though, is the further down the tree you are, the more dependencies everything else has on you. Okay, for example, you cannot create an instance or a subnet, in this case, without having a VPC. Okay? You can't create a VPC without it being in Amazon, because that is a concept within Amazon. In Azure, it's something completely different. It's called a resource group. So what it's doing is it's telling you, it's actually breaking down the relationship between your system and showing you, this is the directed acyclic graph. This is actually walking the tree every time. And I'm sure there are other tools that can, you know, join into our graph model and actually draw this out. I might actually speak to Simon about seeing if we could do something interesting there, because this could be really cool in order to do it. But the main thing is that it's showing you that there is a graph available. So if I run the command terraform plan right now, it should tell me that it's going to add something in the region of 26 new resources. 26, yeah, there or thereabouts. 27, there you go, I wasn't far out. And of course, the SSH key is still in there from before because it doesn't destroy that until I tell it to be destroyed. And it's going to create all sorts of stuff in there, and we're just going to apply it. Please don't blindly apply your Terraform configs. This is purely demo basis. Okay? You would save that plan as an output, and then you would apply that output plan. Let me give you an example. I'm a developer working at 5 o'clock in the morning, and I've had a load of beer, which usually happens for me, and I've written some code, and I think it's a great idea, and I think, I'm going to Terraform plan that, but I won't apply it yet. And then, of course, another developer comes in the morning and actually adds more code to it and breaks my code. Now, if I do a Terraform, if I just blindly Terraform apply in the morning when I wake up, then I'm going to take my code and their code and put it out into production without them being potentially ready for production. So if I save my plan, then I can apply only the changes that I want, that are very much tested and that are available to go to production. It's really important. It's a really important concept. Don't just blindly apply stuff to your infrastructure. Please don't. Because you'll probably open a bug on GitHub, and we'll probably have to spend some time looking into it about what's going on. This is giving me an output right now of everything that's going on. And this is actually talking to Amazon live. Oh, wow. That went really quick. Let's go to VPC. And we'll see we have a VPC called Devternity. and we'll see now that we have some subnets called devternity, and we'll see we have some route tables called devternity, and we'll see that we have a couple of NAT gateways that are currently pending, and that's these pieces of infrastructure right here. Terraform understands at what point, if it's still creating, it waits for it to be created, and then it allows you to continue. So let me zoom on, let that happen in the background. Let's create an instance. I'm going to use OpenVPN. Okay. Again, I must stress, this is not production-ready code. This is just to show you that you can actually create something and actually load code into your environment. Okay. This is a module called VPN. What it does is it spins up a security group, and it spins up an AWS instance. It will allow me to connect to the instance using a public IP address and download a client file that I can use in my VPN software. And lastly, I can use what's called Terraform output. Okay? So outputs are useful pieces of information for operators that they can see on the screen after an apply has happened. And there we go, we can see 27 resources added. So Terraform get to get the new module code. Terraform plan should show me that there are 2 new resources to add. Has anyone any questions while this is happening? Question?
My question is, what if you apply this plan to your production infrastructure that already has lots of stuff?
So the question is, what happens if you apply the plan to your production infrastructure if it already has a lot of pieces of infrastructure? Okay, so Terraform itself will, it's a good question. Terraform itself will not change any of your current infrastructure. Okay? Terraform will only manage the infrastructure that you tell it to manage. The issue here, in your case, would be if you have a VPC that has an existing CIDR range in the same region as you have told Terraform to create another VPC with an existing CIDR range. Okay, because then you would have 2 VPCs that have conflict in ranges that the IP addresses could get mixed. So that, for me, would be the only real use case of where it could be bad, because if I've told it to spin up 2 machines and you have 112 other machines in your account, it's only going to manage those 2 machines and nothing else. Make sense?
Yes, but my question is more like, what if I have lots of existing legacy infrastructure and I want to start to manage? Got it. So the question is can you import existing infrastructure into Terraform? Partially, yes. Partially, yes. Okay. We're working on features right now that will allow you to run Terraform import. So Terraform import, the type, which is AWS subnet, .mysubnet, and then the subnet ID, and it will go off and it will import that into Terraform configuration. Okay. This is very early on in that feature, very early on in that feature, so use it wisely and be careful with it, but it is available to use. There was another question over here. On the left? No? Okay. So we're just going to Terraform apply that. If I can spell it again. And if we go to the console, we should see that there will be a machine that starts to spin up. Hopefully very shortly. Any other questions while that's writing?
What about...
Oh. You can go. Go on. You go first. You go first.
What about Terraform get command?
Okay, so the Terraform get command. What about the Terraform get command? Modules do not have to exist locally towards your Terraform config. Modules can actually exist in an S3 bucket, packaged, or they can exist in their own Git repo. Okay? Terraform get is effectively going off and downloading the module source for that specific version of the Git SHA of your module so that you can work against that. So in this case, the VPC, think of your network team working in a VPC. They're building the VPC environment. They're tagging the VPC module. And every time they need to upgrade, you would just go Terraform get and get the new one. Make sense?
Yeah.
This man.
The question was, let's say you want to create a key pair, but there is already a key pair and they conflicted with one another. Is Terraform smart enough to understand that key pair exists and just update it instead of...
So the question is Terraform clever enough to understand if any of your infrastructure that's being created is already in existence?
Yes and no. There are certain pieces of Amazon that will allow you to overwrite, okay? But usually when you create a new resource in Amazon, Amazon will tell you it already exists, you can't do that. There's already something with that name already in place. And Terraform will report that error for you. So, we can see right now that we have an instance. It's created the instance, it's currently running. It's got a name. But look, it actually has given me valuable output at the bottom. Okay? It's given me the IP address. Please don't hit it because it's costing me money. It's given me an SSH command if I really want to go and hit an SSH. And if I visit it in the browser, it's not quite ready. It hasn't finished doing its status checks because it's a very small machine. And hopefully this will happen very quickly. Now, let's just move on. Let it happen in the background. The last thing we're going to do is we're actually going to spin up a cluster of machines. Okay? This is using one of our tools called Console. Okay? Console is a quorum-based tool that will allow you for service discovery and all sorts of key value management and stuff like that. That's not the important thing. The important thing is I actually am using a data source right now in order to talk to Amazon to get a current image that I have created, a versioned image of my software. Okay? Going off, using the data AWS AMI, looking for a specific filter, and that's going to bring me back an AMI ID. Okay? I then take that AMI ID and pass it into a module, which will spin up, based on an autoscale group and launch configuration, a number of machines. It will spin up 3 machines. Okay? But here, the reason I put the VPN in place is that it's going to do this behind and inside my VPC. So I would actually need to connect to my environment in order to go and see it. Let's just save it, and if we terraform get, terraform plan should tell me it's going to add another list of resources. So autoscale groups, load balancer, etc., etc. It's going to add 8 new resources, and we're just going to allow that to apply in the background. I can connect to the machine now. Now you can see why it's not production-worthy code, because it's an SSL certificate that's self-signed, and it has a very, very super secret password. Okay, the password in this case may or may not be password, and hopefully, if I try and tell it to allow me to log in, I don't understand why that's slow. Come on, machine. There we go. So open VPN, password, and we're going to log in, not now, and we're going to download a client certificate. Okay, I've clicked it, it's automatically gone into my VPN software called Viscosity, and it's now available to connect up here. Okay, we'll connect to it in a second. And you can see it's actually, the Terraform apply in the background is going off, and it's actually creating my machines, and it's actually spinning machines up. If I go back to AWS, I refresh, I should see 3 new machines being spun. 1, 2, 3. They're currently initializing, they're currently launched right now, and they're all based off the same AMI ID. Where did that AMI ID come from? During the keynote, I ran a process called Packer, okay, Packer build, okay, which takes a pre-configured set of systems. I have like 10 minutes, including questions, so hit me with questions if you're going. Okay, so I've predefined what my system should look like, what packages should be installed, what users should be installed, etc. And I've done it right here. Okay, so yum update, install AWS tools, install a specific package from Package Cloud, etc., etc. You can make these as convoluted or as whatever you want them to be. Okay. What I'm trying to show you is I've packaged a piece of software, I have baked that into an image, and then I can use Terraform in order to say, hey, go off and launch instances based on this image. I usually version my Packer AMIs. Okay? So I know that when I launch Terraform the first time, I can launch 0.1. If I make a change to my Packer AMI using my CI tool, because my CI tool builds these for me, and it labels it as 0.2, the next time Terraform applies, it will say, hey, I can change the launch configuration, and any new machines that you want to be created will based off this new configuration. So you're having not only CI for your packages and all your systems, you're actually bringing in continuous integration, continuous delivery for your infrastructure. When it's tested like this, it's beautiful. And you can test it. I can actually layer in some tests inside using something called server spec. And after my AMI is created, I can get my CI tool to start running my tests. They're Ruby-based tests. And I can say, hey, when this AMI is available, it should have Nginx on that AMI, and Nginx should be running. It should have NTP on that AMI, and NTP should be running. You can also say it should be synced against these servers, whatever you want. Okay? One sec, and I'll come right to you. The main thing to notice right now is that I'm actually creating a working blueprint of not just how my infrastructure looks with Terraform, but also how individual instances themselves look. It's really important. Question over here.
So is it possible to use Chroot with Packer? Have you tried that?
Can you use Chroot with Packer? I believe there is a Packer Chroot builder. I personally have not used it because everything I build is in AWS. I use an EBS backbone.
Yeah, but you know, sometimes you need to do decrease time of deployments, and in that case, Chroot.
Yes, you could certainly use it, but there is a builder available for that, yes. So go and check it out and have a look. So I do know people who use it, actually, so there are a couple of people who use it.
It's more than
people with big beards, hide under the floor, eat pizza a lot. But the nice thing is that I'm integrating how I build, deploy, package my software as part of my CI tool. Not a single Docker container has been harmed in the making of this talk. Actually, a lot have been harmed in the making of this talk, but that's a different purpose. So I go back now, because the demo should have passed, and I can see, look, apply complete, 8 resources added, 0 change, 0 destroyed, and I get a URL. Okay. The URL is an internal URL. Okay. It doesn't have any public-facing UI. Let's try and connect to it. Nothing. It's not going to let me connect at all. So we'll connect to our VPN. 7 minutes. Open VPN, not password. And it's just going to connect right now. Hopefully, very shortly. Okay, it's connected. And we have a console cluster up, alive, and well. It's based on an auto-scaling group. What that means is that if one of the instances die, Amazon will bring it back for us. In fact, let's go and prove that theory right now. Terminate. Yes. We should see it disappearing from our cluster. One of the nodes should actually fail their health check. And there we go. The node is failing because it's been terminated. And it's shutting down, and Amazon will replace it. Anyone get paged? Anyone on call for their company? Isn't it the worst feeling in the world when you're paged in the middle of the night because one of your machines has disappeared? It's really not good. I'm recently married, like 9 weeks ago. And my wife, she gets extremely annoyed when I used to be on call, because I used to be woken up all sorts of times in the middle of the night when I had physical infrastructure to manage. When I moved into the cloud world and I put these types of practices in place, I didn't have to get woken up. Because trusting that your auto-scaling group is in place, trusting that your scripts are in place, trusting that your environment is brought back to its existing state will mean that I log a message overnight to Slack that says, hey, just to let you know, that machine right there has disappeared, but we've replaced it with this machine, and everything is happy again. And I wouldn't say much happier, because you're never happy when you're in ops, right? But the main thing is that you can actually be a little bit more confident that you're not going to have crisis time. Don't get me wrong, you still have outages. Okay? There's no such thing as flawless operations, none. And anyone who tells you that and sells you that as a service is a liar. We have failures every single day in our infrastructure. That's just the way life is. In fact, the faster we move as an environment, the faster we move as engineers, the more outages we create. So trying to mitigate those errors by using these types of tools, for me, makes my life a lot easier. And I'm not standing up here and telling you, you must use our tool, because it's awesome. I've been using I've only been working for HashiCorp for 6 months. I've been using Terraform for 18 months, okay, for a year before that. I was contributing code back to the code base a long time before I joined the company. And I couldn't even write Go. I still can't write Go. But it's not the point. It's quite an easy tool to get started with and an easy tool to extend and work with and fix bugs. And if we refresh, we should see a new instance is currently being deployed right now, which is this one, and it's currently initializing at 11:15. And hopefully that will go back into the mix very shortly. 3 more slides, and then I'll stop boring you. Okay, I've got 4 minutes. I said long-running servers suck. There are many tools that can do this same job. Many tools, okay? So you have CloudFormation, obviously, if you're in Amazon. Lots of people use it, lots of people love it. You have Sparkle Formation, you have Troposphere, you have this horrible blob adjacent right here is the Azure Resource Manager. I'm really sorry. I Googled it, and that's what I found. But I've since updated the image. I've just forgot to put it in this slide. The main thing is there are lots of tools that will do this, okay? And if you don't use a tool like Terraform, you have to then go and stitch lots of different tools together. Terraform can not only talk to Azure and Amazon and Google all in the same configuration, it can also then take those values and plug them into your DNS provider. It can connect to your database and actually provision users on your database on your behalf. In InfluxDB, MySQL, Postgres, it can actually get and actually connect to your databases after they have been created. So you can be very confident that when you run a Terraform apply across your environment, it will take your environment to a completely running state. If that's what you've told it to do, of course. Mary Poppendick, who is a wonderful Agile speaker, she asked the question, how long would it take your organization to deploy a change that involved a single line of code, and can you do it on a reliable, repeatable basis? Okay. This was only really ever asked to software engineers. This was never really asked to operations people because they would run and panic. When we work in the immutable world, when we work in the configuration management world, we can work much more effectively and we can make much more fine-grained, much more granular changes to our systems and be confident with them. We can have disposable environments. So in the morning, 9 a.m., you can come in, or a process has actually ran a Terraform apply, it's brought the QA environment up. You know that that environment is exactly the same as production. And then at 6 o'clock, when everyone's gone home, it can run Terraform destroy and take it down again. You don't need long-running QA environments. That would save companies a fortune. Absolute fortune. If they're only available for 10 hours a day. What's your disaster recovery? I'm not lying about this, okay? Somebody asked me in a previous company, what's our disaster recovery plan with Terraform? I printed him out the Terraform configuration and went, there you go. He was like, what do you mean? And I was like, you just run the same commands again. He was like, but what happens if the data center dies? I was like, you change this variable from US West 2 to EU West 1 and Terraform apply. And he was like, what? I was like, let's try it. And we destroyed we failed over a data center from US West 2 to EU West 1, and it took 6 minutes. So we had 6 minutes of downtime. But that was because we were using a Postgres database in RDS, which took 6 minutes in order to provision. So we then realized that you can actually ship snapshots between regions in AWS. So we always kept a snapshot available in a different region. And then when we made that, it was actually a 1 minute downtime. Okay. Netflix are really great at doing this type of thing. They think in this way. They think of disasters. What happens if? What happens when? Okay? When we start to think in this way, this is when we can actually start to build resilient and useful cloud infrastructure. You can't, if you're not thinking in this way, and you're still thinking of like manually racking and stacking, it's very difficult to move very fast. We always usually depreciate the cost of software, hardware over 3 to 5 years. In 5 years' time, the hardware that you're running on right now is literally going to be rusting. Okay? The industry will have moved on so much faster that you need to be able to keep up better. And just to prove that the system self-healed, if I refresh, it added back in my third server. I thank you all very much for your time. I'm going to be around the rest of the day. I have no time for questions right now, but find me outside. I'll hang around outside if anybody has any questions. Enjoy the rest of the conference. Thank you.